Guys, welcome back. We are in the second week of May. We are cruising through this and we are hopping into our very last topic of your 7th grade year. We're looking into electricity, electrical energy. So what we're going to do is we're going to get right down into the how it works. When I plug a battery into something, or when I plug my phone charger into the wall, how do I get electricity to do the job that I need it to do? And we're going to start taking a look at some electrical circuits. And I really wish that we were together in class to get our hands on these and build these, but fortunately we're going to be able to do some designing and some building of some circuitry online. So let's start by taking a look at what is an electric circuit. An electric circuit is just simply the path that an electric current has to follow. So this is a very simple version of an electrical circuit. This would be an example of something like in your remote control or a battery controller of some kind. You begin with your source of energy, which in this case is the battery. Now, if you're looking at the circuit diagram, a battery is represented by this symbol of alternating long and short lines. So instead of drawing a picture of like a AA battery or a D cell battery, we're going to use electrical symbols here, kind of like an architect designing electrical circuits here. So when you plug the battery in, if you've ever done this, and I'm sure you have, you notice that there's a positive end and a negative end on the battery. And it's really important that you understand which end goes where. If you've ever reversed your battery, putting the wrong end into your appliance, then nothing seems to work. Okay, so on our diagram, it's going to be very important to mark the negative. Let's go ahead and choose a color. There we go. Try again. The negative and the positive end on the battery. Now, this solid line that we are connected to here, that is the symbol for the wire. And the wire is going to create that circuit path for the electrical current to flow. But here's where we need to pause and focus in for just a moment. How in the world do I get stored energy out of a battery and into a wire? Because if you just pick up a battery, we've already talked about its form of energy. It's chemical energy. The energy is stored inside, and it's not electricity inside of that battery either. It's literally stored chemical energy. But here's what happens. When you plug that stored chemical energy of the battery and you connect it to a conductor like a wire, you are pulling out electrons from within the battery and into the wire. And the reason they start to flow out of the battery is something called potential difference. We know that energy likes to be equal between two objects. So when I put my battery into the wire for the first bit, the battery has way more stored energy than the wire, which doesn't have any at this point. So this is going to encourage electrons to flow out of the negative end of the battery and into the wire. And as current flows out of the negative end of the battery and into the wire, it is going to continue to pull out those electrons until the wire and the battery have an equal level of energy. And that energy in the battery we like to call volts. So we have either like 1.5 volt battery, 3 volt battery, whatever you happen to have on hand that you are plugging in. That potential difference between the battery and the wire is what is going to pull your electrons out of the negative end of the battery and into that conducting wire. This creates the current. The current is simply the flow of electricity along the wire. So we need that initial energy source, which in this case is the battery, to provide the electrons that are going to flow into the wire to create the current. Okay, let's continue along our circuit here. As my current is traveling along the wire, it's going to meet something we call a switch. Now, this is the symbol for a switch. It almost looks like a door on a door hinge here. But in this case, this switch is open. Open meaning the switch is disconnecting the wire. There's a space, a gap between the wires here. Now, when the current, the electrical current, is flowing and it meets the switch, if the switch is open, meaning it's not connected, that current can't hop through the empty space and continue its path on the rest of the circuit. That open switch is going to stop the flow of current, and anything plugged into the circuit is not going to be able to work. It's the same idea as when you turn off your light switch. Your lights turn off, but what you really do is behind the wall, you open your switch, meaning current can't continue to light the lights in the room. Now, if we were to close the switch, so let me go ahead and get my eraser going here. There we go. No more open switch. And I'm going to go ahead and close that switch. That is like flipping on your lights. What you are really doing is putting that circuit back together. You are connecting it wire to wire so that this electrical current can continue on its path and into the object that you are intending to work. In this case, we have 3 lamps that are plugged into this circuit, and these are the symbol that we are going to use for lamps. Now, lamps can also be thought of something called a resistor. A resistor is something that slows the path of current. So essentially, if you are asking an object like a lamp, like a fan, to use current as it goes through the circuit, it's going to be a resistor. It's using up current and it's slowing current on the way back to the battery. Okay, so current, if my switch is closed, current is going to continue to run through lamps A, B, and C, all the way back into the positive end of the battery. That circuit has to connect back into the positive end. That way, current can begin to flow. Now, over time, you may notice that you have to replace your batteries and things. So if I have this current flowing consistently again and again and again, completing its circuit path, and each time the current comes out of the battery, it has to provide energy to these 3 lamps. And when it does that, energy is transformed. So it will go from electrical energy to radiant or light energy and some thermal energy each time it passes a lamp. So for every path along the circuit, there is less energy, less volts returning back to the battery because energy is being transformed. So over time, I have to replace my batteries, giving a fresh set of volts to transform into electrical energy. So since we can't get our hands on these together in class, I am going to link this as well to our Google Classroom board, but this is a digital circuit builder. So in this case, we're looking at what we just designed, which is a series circuit. A series circuit means that there is only one path for current to flow. So I have essentially one box, one square of wire here. And if I choose to plug in my 3-volt battery, I have some options on how to complete the circuit. So I can add extra wire, I can add a bulb or 2, I can add a buzzer if I like, and I can add a switch. Now, if I look at this circuit design, nothing is working at the moment because my switch is open. So if I close my switch, that connects my circuit and my lights will illuminate and my buzzer is going off in my earpiece here. As soon as I open the switch, I'm essentially disconnecting the circuit and the nothing on this circuit will work. This is what is unique about a series circuit. There is only one path of energy to flow around the wire. So if any point on that circuit is broken or open, if a switch is open, not a single object on that wire will work. So there are several different versions of a series circuit here. You have this one. Whoops, we just did that one. Okay. It can look a little bit different. depending on the format, you can rearrange these things. So I can put my battery, my bulbs, my switches in different places. But if I take a look at this, again, only one object is broken. This switch is open. Until I fix that broken area on a series circuit, nothing else will work. Same thing here. If one area on the series circuit is disconnected, nothing else is going to function. So here's what I would like for you to practice this for the start of this week. In order for you to become familiar with the vocabulary of circuits, things like the flow of electricity, we have talked about batteries, we have talked about resistors, and we have talked about series circuits. You have a PowerPoint that is posted to Google Classroom. At the end of that PowerPoint, you have 8 questions. You can find the answers to these questions within the slides of the PowerPoint. This is not challenging. It's simply a search and find so that we have the basics of circuits so that we can get into some circuit design. So I really am hoping that we can practice these, get to know our different circuit terminologies, be familiar with some of the circuit symbols, and then we can design some really cool circuits virtually online together. All right, this is your first practice so that we can start designing. I hope you guys have fun with it. I'll see you later. Bye-bye.